and to reduce inflammation. As we have seen, this is very important in the patients with COVID-19 disease. Now, when there is a deficiency of zinc, there is a very clearly reduced activity of different immune cells like phagocytosis. Critical neutrophil functions are downregulated. The natural killer cell function is weakened. There is a reduced lymphocyte number and activation. And also the antibody production is reduced, which has been shown in different studies with, in which patients were vaccinated, and those with zinc deficiency had lower antibody immune response. Imbalanced T helper cell cytokine secretion, which reduces the interferon gamma production. It increases the risk of thymic atrophy, and by this increases the risk of infection. And altogether, zinc deficiency increases inflammation, inflammatory condition. Now, a part of the effect of the immune system, zinc has also a direct antiviral activity for a number of RNA viruses. It is has been shown that intracellular zinc inhibits the replicase, that is an enzyme necessary for the replication of the SARS coronavirus, and it had also a very potent inhibiting effect on papain-like protein, and that is a viral protease of SARS-CoV, which is very important for its virulence. So there are direct antiviral effects on these viruses. And since SARS-CoV-2 is very similar to SARS-CoV, it is very well possible that this direct antiviral activity applies also to this SARS-CoV-2 virus. Here we see a schematic view of the effects of zinc by Skolny and Rink and et al., which is being recently published. And we see the effect and the importance of zinc for the mucosal membranes, for its barrier function. It has an effect on the replication of the virus. It has an effect of the interferons and stimulating the antiviral immunity. It reduces the inflammation, and there are also studies showing direct effect against the Streptococcus pneumoniae, which often causes, that is a bacterial infection that often causes co-infection in viral respiratory infections. Now, let's have a look at the risk factors for zinc deficiency. And there are a number of studies showing that with increasing age, there is an increased risk for zinc deficiency. This was a study in 2006 in which was found, this was done in Europe, that 31% of the subjects had lower serum zinc concentration. And this is a review from 2009 from Haas and Rink, and there are 20 studies involved, and there was these studies were all showing that there was a significant decrease of serum zinc concentration with increasing age. And similar effect was also found in a very good study done in Norway, an observational study, just a sample of more than 1,500 people, really representative for the whole population, over 67. And in this group, there was found a zinc deficiency in over 10% of the people. So, and also here it was showing that there was a significant decrease of serum zinc concentration with increasing age. Then there are studies done on diabetes. Also, diabetes seem to increase the risk of zinc deficiency. And that is because in diabetes, patients excrete more zinc in the urine. And this was shown in a study, one observational study of 82 persons. And there it was found that with a higher level of glycated hemoglobin, the serum zinc concentration as well as intracellular zinc concentration was significantly lower. So the glycated hemoglobin is a representation of the glucose levels on the long term. And then there was this meta-analysis done on 52 studies were included, so over 20,000 diabetic patients, and there were altogether there was a significant lower serum zinc concentration in control groups. Then there are different antihypertensives that also seem to reduce the serum zinc concentration. These are studies done on diuretics, and these different diuretics or diuretic-like, thiazide-like diuretics significantly lower the serum zinc concentration or even intracellular zinc concentration, although it can also in white blood cells increase zinc concentration with this clopamide. Anyway, the zinc balance is disturbed in this. These are all relatively small group of patients. There's clinical studies with 10, 15 up till 20 or 30 people, but all over. Often it is found that also here in the case of ACE inhibitors, there is a significant decrease in serum zinc concentration or intracellular zinc concentration after the use of about 3 up till 6 months of the drug. Now, most of the trials, they did control very much the zinc intake, which is very important. But this one of Suliburska in 2018, they did control the zinc intake during the entire study. And also when the zinc intake was controlled, there was a significant decrease of serum zinc concentration after 3 months of use of these drugs. There are also signs that calcium antagonists, another group of antihypertensive, can decrease intracellular zinc concentration or serum zinc concentration. And there are another group of angiotensin II receptor blockers that are also capable of reducing serum zinc or intracellular zinc concentration after 4 weeks or 3 months of treatment. Although there were no, in this clinical trial, the last one, the underlying, there were no such effects found. And in beta blockers, another group of antihypertensives, there were no they remain inconclusive about the effect on the serum zinc and intracellular zinc concentration. Apart from antihypertensives used by cardiovascular patients, also the statins for lowering cholesterol are widely used. And in a review from 2019, including 29 studies with over more than 1 million participants using these drugs, there was a 10 to 45% increased relative risk for type 2 diabetes. And we have seen in the previous slides that type 2 diabetes increases the risk of zinc deficiency. Now, this is not strange because in other clinical studies, it was showing that after just 4 months or even 2 months of therapy, there could be a significant decrease of serum zinc concentration. Now, what it is all about is about zinc balance, because the zinc balance depends on the amount of what we get in by dietary intake, and what we lose, especially by zinc urinary excretion. So the dietary intake depends, or the risk of less zinc absorption increases with malnutrition, with size, especially when a lot of refined products are consumed, or in patients with low appetite. And there can be also an interference with zinc absorption, like fibers and phytates. They are more in plant foods, and they are inhibiting the absorption of zinc. Also, a high calcium or iron intake, when it is supplemented, they can interfere with the absorption of zinc. And some medications like protein pump, proton pump inhibitors, they can reduce. And there's the possibility of digestive disorders and gastrointestinal surgery that can interfere with the absorption of zinc. On the other hand, zinc excretion is increased with alcoholic drinks, with diabetes. Also, heavy smoking can increase the elimination, the excretion of zinc. And as we have seen, different medications have this possibility. And about many other pharmaceuticals, drugs, we do not know what is their effect. Now, there is another important issue about zinc balance in the body, and that is about the infection and inflammation. Because during infection or during inflammation, there is a sequestration of zinc into the liver. So the zinc goes accumulated in hepatocytes and is in cells bound to metallothioneins. So there will be less zinc available for the immune functions in a high inflammation or high infection state. So here is a summary of the important effects of zinc. It is essential for the immune system. It is for the innate immune system, for the adaptive immune response. It has an anti-inflammatory effect, an antioxidative effect, and it has a direct antiviral activity for a variety of viruses. And the balanced zinc homeostasis is thus essential for a proper antiviral immunity. Most important in the beginning of the infection, when a person contracts the virus, and the innate immune response is into action, as we have seen in the previous presentations also of Dr. Palmieri and Andy Suter and Sinanayake. So the innate immune response is very important, and zinc is involved in that. Now, another issue is the small functional reserve of zinc. And this zinc is absorbed, and then we have a functional reserve pool, which is directly available for the immune system to use to counteract any pathogenic invasion. But the zinc, the functional reserve of pool, will be diminished during inflammation and infection because of transport to the liver and the binding of zinc to metallothioneins. And the functional pool could also be reduced by increased urinary excretion. So who are at risk of zinc depletion? They are the elderly, men more than women, vegans, vegetarians with a low intake of zinc, pregnant breastfeeding women who need a higher intake of zinc, and alcoholics. Now the drug use we have seen that there are different drugs reducing serum and intracellular zinc levels. And then there are different disease states like overweight, type 2 diabetes, type 2 diabetes, digestive disorders, gastrointestinal surgery, and untreated inflammatory conditions. And inflammaging is the situation of a low-grade inflammation in the body going on when we get older, and it is especially going on in patients with obesity and type 2 diabetes and others at risk for chronic diseases. These are important symptoms of zinc deficiency. There's the impaired immunity. So you don't, if there is a mild zinc deficiency, you don't recognize that in the patient until they encounter an infection. So recurrent infections can be a symptom of zinc deficiency. Then on the gastrointestinal level, there is an anorexia, hence a low appetite, impaired digestion, and nutrient absorption is reduced, and it can, in extreme cases, lead to diarrhea. On the nervous system level, there is a loss of smell and a loss of taste, especially in the beginning of a zinc deficiency, is that these are early symptoms, also night blindness. And these symptoms, which I have marked in yellow, these are also symptoms that we see in patients with COVID-19 disease. Now, in extreme cases, there can be skin lesions, there can be hair loss, there can be growth retardation in children, and it has also effects on the reproductive system when there is a long-term deficiency of zinc. Which are the dietary sources of zinc? Zinc is mainly available in fish and seafood. It is also in meat and in vegetable foods, especially nuts and seeds are high in zinc, and also legumes contain zinc. So you don't need a diet of animal products. You can find enough zinc if you use these products enough on a daily basis to get enough zinc. These in extreme, in the patients at risk, we should consider to take oral zinc supplementation for improving the zinc levels, especially patients with overweight, diabetic patients, and patients taking drugs that are lowering the level of zinc. So the usual dosage is about 10 to 15 milligrams a day, and preferably the organic forms like gluconate, citrate, and picolinate instead of sulfate or oxide, because the organic forms are absorbed much better than the salt forms. The upper intake level of 14 milligrams, so here is missing milligrams, is 14 milligrams a day for adults. And in children, of course, the dosage and the upper intake levels are lower. And an advantage of the oral zinc supplements is that there is hardly any interaction with drugs. And there is some interaction with some antibiotics. But when you take the drugs separate from the zinc, a few hours in between, then there should be no problem. It should be avoided to use excessive zinc because it can reduce the copper absorption and it can impair immune function as well. Too much zinc inhibits the function of T and B lymphocytes, so be careful when supplementing zinc. Too much creates damage as well. So these are the conclusions. Zinc is a critical factor in antiviral immunity, and zinc deficiency is prevalent also in high-income countries. So, and unfortunately, doctors are not so much aware of that and are not aware of the interaction of drugs with the zinc status of the patients. And disturbed zinc homeostasis contributes also to inflammation. That is one thing, but inflammation makes also less zinc available for critical immune functions, as we have seen for the immune functions of the innate immune system. So zinc could be a targeted nutritional prevention and intervention measure for risk groups, patients at risk for zinc deficiency and patients for COVID-19. In fact, we can say that the groups, the patients at risk for zinc deficiency fit nearly one-to-one with the risk group of the COVID-19 for severe progression of COVID-19. So for the risk group, it is important to supply sufficient zinc, and we should also take dietary measures for reducing inflammation and inflammation. And of course, we do need more research in the role of micronutrients in antiviral immunity for zinc, and especially important the drug micronutrient interaction and the effect of that on the immune system. So I've written a paper about this, and this is published in the British Medical Journal Nutrition, Prevention and Health. So everyone interested in zinc and the effect on the immune system in COVID-19 can access to this paper. And there are also other interesting papers on the British Medical Journal Nutrition, Prevention and Health as well, concerning COVID-19 disease, for example, on vitamin D, vitamin C, and so there are some very interesting things to consider. Okay, thank you very much for your attention, and so this is the end of my presentation. Hello? Hello?
Hello.
Yes.
Yeah, hi. Thank you so much for joining us with us, Dr. Pan Zhang. Now, Pan Zhang is from OncoImmune INC from USA. Now, she's going to speak on a phase 3 clinical trial on CD24FC as a non-antiviral immunomodulator in COVID-19 treatment. Thank you so much for joining us, Dr. Pan Zhang. Now you can go ahead with the presentation.
Very welcome.
Yes.
Hi, hello. Can everybody see my screen, or is a split screen?
Yes, we can see your screen. Better you can do slide share. Yeah, you can click on that. That icon is there, right, where your arrow is there. So there, if you can click, it will show slides. Yeah, slide. Yes, perfect. Yes, perfect. Yeah.
Yeah. So sorry. I was all of a sudden getting earlier.
Yeah, because there are few speakers. They're coming and going, and they don't know when they're going to join. So yeah, hopefully you are there on time. So we moved the presentation, a little earlier. Yeah.
Yeah. Now it's better. The screen.
Perfect.
Hi, hello, hi. My name is Pan Zhang. So I work in OncoImmune. I'm the chief medical officer in OncoImmune. This is a company located in the Rockville, Maryland. I'm also a faculty at the Institute of Human Virology in University of Maryland. So I just want to get started with this title is CD24FC. This is we are carrying out a phase 3 clinical trial. This is a non-antiviral biological immunomodulator for the COVID-19 therapy. So at the very beginning, not that many people familiar with the CD24 and this Ciglet. So this is actually a pathway that the our CEO, Dr. Yang Liu, discovered in 2009, that this is a very important checkpoint in the innate immunity. So this CD24 and the Ciglet actually recognize a lot of this danger-associated molecular patterns. When cell death, a lot of the content inside the cell actually release into the outside, and the lymphocyte actually can recognize all these signals, these molecules inside the cells. And these molecules also can have immune response. The CD24 Ciglet is an important, is an innate immunity checkpoint to control the host response to these danger-associated molecular patterns. This pathway also have many other functions, like a T cell activation, like phagocytosis, and also this leukemia relapse. So today, but I'm going to more focus on this inflammation part. So during this inflammation, so CD24 is a GPI linkered molecule. So it's mostly have a lot of this extracellular domain, and then with insert into the cell membrane. So the CD24 itself doesn't have the intracellular domain inside the cell. So how do they give the signal? The signal is actually going through this Ciglet families. Here's the example is the Ciglet G or the Ciglet 10. So these molecules have a lot of this intracellular domain. They are actually have this ITIM domain, this inhibitory protein kinase, and they bind to the SHIP1 and give a very negative signal for the NF-κB activation. So as everybody knows, the NF-κB control multiple this cytokine, chemokine, inflammatory factors activation transcriptions. So CD24FC is a product of the OncoImmune company. So this is a CD24 fusion protein is made by the CD24 extracellular domain fused by the human IgG FC domain and make it soluble. So you can inject them IV infusion as a drug to human. So there's the mode of the action, the mechanism of action really have twofold. Number one is the CD24 directly bind to a lot of these danger molecules. Then they can reduce the toll-like receptor ligands. So there's a less molecule will bind to the toll-like receptor to activate the immune response. Then CD24 also bind to the Sigla-G, Sigla-10 to give a negative signal, directly inhibit the NF-κB activation. So we have been doing this laboratory research for quite a long time for Dr. Yang Liu, who already working on this molecule for 30 years. So we have found this is a very important modulator for the inflammation, and then inflammation itself also control the majority of the disease process. So we already have many of these preclinical data showing this in GVHD, in the HIV, metabolic syndrome, autoimmune disease, and this immunotherapy-related adverse event, and the chemotherapy, radiation therapy, protection. So there's a lot of things we are doing. And for the clinical part, we already complete the phase 1 in healthy volunteer, and then 2 phase 2 clinical trial in the GVHD prevention. This is graft versus host disease. When leukemia patient have this, the cure method is really bone marrow transplantation. When they have the transplantation, the graft versus host disease is a major issue and cause a lot of transplantation-related mortality. But today we are trying to focus on the COVID-19. So we think this CD24FC, especially this innate immunity checkpoint, really target on the very, very key features of the COVID-19 pathogenesis. But this part, including this lung inflammation, so this is pretty much knowing that this causes pneumonia, the major effect is in the lung. But then there's also other things. Then there's a lymphopenia. There's a lot of patients come in, the lymphocyte numbers really, really low. And then there's a cytokine release. The cytokine release is slightly different than the CAR T treatment with the cytokine storm. The number is not that high, but the number is increased, and a lot of cytokine increase. And then the other important feature is coagulation. There's an abnormality on the coagulation. Many young people have sudden death with a stroke, with heart attack. And this is also very important part of this COVID-19. So we're talking about that one by one. For lung inflammation, why we say the CD24FC can work. So we have this monkey data. So this is what the non-human primate data. We're actually trying to use this SIV. So very similar to HIV, the SIV also infect the monkey, cause a lot of this AIDS symptoms. So in this experiment, we infect the monkey with this SIV. And after a certain time, they start to show this diarrhea, this kind of lost weight. Then we separate them into 2 groups. One is have a controlled normal saline IV infusion. The other is treated with a CD24FC with a 3 treatment. So as you see from this, the panel B with all this histology. So on the saline treatment group, the 5 out of 6 monkey really have this very severe lung pathology. They have a very thickened wall and a very thickened fibrosis formation. and it's impossible to have air exchange for oxygen exchange. But then on the right-hand side, there's a CD24, there's 6 monkey over there. 2 got sick, but 4 of them is actually pretty much this normal alveolar walls. So we can reduce this viral pneumonia from 87% to 33%. And when we talk about lymphopenia, lymphopenia is a very important feature associated with COVID-19. And then the other viral disease with that feature is really the HIV, the AIDS virus. So this is the paper, the figure coming from the paper, coming from this Wuhan, when they compare the healthy people with people with COVID, whether they are not in the ICU or in the ICU, the common feature is there's a dramatic decrease in the total T cells, including the CD4 T cells, CD8 T cells. So this lymphopenia is a very, very common feature. We have the experiment in the humanized mice. So all these lymphocytes, these myeloid cells are all coming from human. They put into the immunodeficient mice to make its immune system is human. So this is a humanized mice. Then you can infect the humanized mice with HIV virus directly. So when we look at this panel, especially the C and the D, so this is when we infect the humanized mice, then later on treat with C25C. So this R3A is a virus name, then this have a lymphocyte decrease. But then when you're adding the CD25C, the lymphocyte is not dead. They are maintaining the same normal levels. And another important feature is really there's a lot of T cell exhaustion, even though the T cell not dead in the COVID patient, the T cell is exhausted. They have very high PD-1 expression that already shown in several papers. So here in this HIV models, we are showing that with the CD25C, we actually can lower the PD-1 markers in both CD4 and CD8 T cells. The CD24FC can prevent the T cell death and to prevent the T cell exhaustion. Another feature is the cytokine. So this cytokine release syndrome also contributes a lot of this pathogenesis of COVID-19. So this is from 2 papers showing this disease progression, different date in the COVID, showing the increase of the interleukin-6, interleukin-10, 2, interleukin-4, TNF, and the INF, the interferon gamma. And then the other one is really with the severe case and the moderate case, the severe case showing higher cytokines expression. So this is actually the data coming from the CD25C treated with a healthy volunteer. So people is not sick. So from the blood, you cannot detect any major change because everything is in the normal range. But then we have the patient's blood sample, the peripheral blood cells before the treatment. So day 0 before the treatment, and then the day 3 after the treatment, single dose. Then we do the RNA-seq. From the top left-hand side, is actually see majority of the genes have downregulation in the RNA expression. And many of this significant downregulation is on the cytokine, chemokines. And on this heat map, you're just looking at the shape of this. So from the heat map, the first 4 is from the day 0. And then the other 4 is from the day 3. So the first 4 is really a lot of this red, orange, and yellow. But then when you come to the right part 4, there's a lot of blue. There's a lot of downregulation decrease. So they're including this interleukin-6, a lot of this chemokine CCL, and also the downregulation of the toll-like receptors. And then many of these transcription factors that control the cytokine expression also downregulated. So we actually did the real-time PCR and showing indeed each individually, there's a TNF-alpha, IL-6, the chemokines, they all have significant decrease 3 days after the CD24FC treatment. Then we go to the last part, the coagulation. So this is the figure showing this deep vein thrombosis in the patients with COVID-19. This is just a hospital admission and at 48 hours. And this a lot of this already have like 79% this have this different degree of the deep vein thrombosis. So this is a very, very important feature. So right now, there seem to be the mortality seem to be decreased in the hospitalized patient. It's really, we recognize this feature, start to give the patient the heparin, the other, this reduce the thrombosis. So this is same data set coming from the RNA-seq, from the healthy volunteer phase 1 data. We can see there's 6 different genes. They are important to regulate coagulation. And in our data set, we show the significant decrease. So CD24FC also reduce this coagulation-related gene expression. So we think this CD24FC can really target the most important pathogenesis features of this COVID-19. They target on the lung inflammation, they target on the T cell loss and the exhaustion, they target on the cytokine release syndrome, they target on the thrombosis process. So we designed this phase 3 clinical trial with very simple, just make it a randomized, double-blind, placebo-controlled trial. So this is a phase 3 clinical trial. We plan to have 230 patients, adult patients. They all have a severe or critical COVID-19. And we one-to-one randomize them. Half of them receive CD24FC, half of them receive the placebo. The treatment is very simple, just on day 1, single dose, CD24FC, 480 mg, and IV infusion for 60 minutes. So study duration, 28 days. The primary endpoint is time to improvement. So it's exactly the same as a remdesivir clinical trial. So these are very busy slides. We include the inclusion criteria, exclusion criteria. So important part is really want to show this NIAID 8-point scale. So 1 is death, 2 is on the intubated, on the invasive mechanical ventilator. And our patient population is this 3 and 4. The patients hospitalized on the high flow oxygen device or the non-invasive ventilations. And all the patients require to supplement oxygen. So they are saturation oxygen level have to be below the 94%. So the primary objective is really just compare this CD24 treatment group with the control group, the placebo group. Which one's doing better? Which one can get patient discharged from the hospital quicker? Which one have the lower mortality? And the primary endpoint is this time to improvement in the clinical status from this scale 3 or 4 to upgrade into the scale 5 or higher. So scale 5 is really, you still, even though you're still hospitalized, then you don't need oxygen support anymore. So the major secondary endpoint is really this overall mortality rate at the day 28, and also on day 28, patients either die or still in the ventilator. So we currently now we already enrolled more than 120 patients, so already halfway through. So this is the very beginning with the first 34 patients. We summarize their demographic and clinical characteristics. So the median age is 50, and there's 70% is from the Hispanic. So a lot of this relative younger patient, they are these essential workers. They still go to work. So these patients have a much, much higher risk will get the COVID-19 disease. But we also have a big group of the patients really on the higher end, age over 65. So the patient also have many other existing conditions, diabetes, higher lipid, hypertension. So quite interesting that we really have this cancer patients also quite a lot of this COVID-19. And the median duration of the symptom onset to the first dose of CD25FC treatment is 10 days. So right now we have 120 subjects consent, 117 randomized, and 113 dosed. So in this study, we have two interim analyses. One is the first 70 patients to do the futility analysis. And the second interim will be when we achieve the 146 event, we'll do the second interim analysis. So right now, we just have the first 70 patients reach the 28 days. So we are going to do this interim analysis. There's a lot of this data cleaning to get everything ready for this analysis. But very interesting is that we, from all the patients we have been dosed, we never see any infusion reaction. Remember, this is a protein drug. We never see any infusion reaction. We don't see any drug-related adverse event. The most important thing that we can see immediately is this extremely low mortality rate. So this first 70 patients, we have 0 7-day mortality. We have 3 patients, so this come to the 4% of the 14-day mortality. And we have 7 patients pass away during this 28 days. So it's a 10%, 28-day mortality. So remember, this is still the blinded data. So only half of the patients using the CD24FC, half patient is a regular supportive care. So we have to put everything into the content. So we need to know what's the usual, your control group, what's the historical control. So even though this historical is only 6 months, but still this Oxford recovery trial is really have the largest number of patients that we can be used as our the historical control. So in this trial, we have been lauded dexamethasone is really work. They reduce the mortality. So they have this panel A is all participant, and then panel B is a no oxygen support. So that's not our patient. Then there's oxygen only. And then this invasive mechanical ventilation, the panel D is also not our patient. So our patient is really this panel C, the oxygen only. So in this case, I blow it up and also overlay our mortality rate figures. So on this little bit red and the gray color, this usual care, dexamethasone. When we look at the day 14, so the usual care is about 21%. And with the dexamethasone, they coming down to 18%. But then in this even blinded data, CD25C with the placebo blinded data, we have a 4% at day 14 and 10% on day 28. So this is a really dramatic decrease of the mortality rate. Let's compare with remdesivir. That's another successful drug already emergency authorization use in US. So this remdesivir have 2 New England Journal of Medicine papers. One is NIAID remdesivir trial. So this they are using the 14-day mortality. So this placebo 12%, remdesivir 7%. And then this Gilead, this own trial, 5-day treatment and a 10-day treatment. They have 14-day mortality. One is 8%, one is 11%. So compare in our group, we have 4%. And in our blinded data set, we have 43% is in this high oxygen flow critical patient. And in remdesivir trial, the 5-day treatment, 10-day treatment, there are 30% critical patients. So our patient have more severe and critical case than the remdesivir trial, but we have a better mortality rate. And when we compare this covalence and plasma data, there's also the dramatic difference. So this is coming from the 20,000 patients using this plasma treatment. And overall, 20,000 patients, they have 8.56% 7-day mortality. And if we just compare the patient without mechanical ventilation, there's 12,000 patients. They have 6% mortality. And in our case, with 70 patients, half of them using C24FC, they're 0% at 7 days mortality. So the other treatment is the most lauded, and the US government give $200 million to support either this Sanofi's sarilizumab or the Roche tocilizumab clinical trial. They all fail in the phase 3 randomized clinical trial. They don't show the difference. They don't improve the mortality rate. So there's a lot of this retrospective studies. They also have this 13% mortality rate and all different numbers. Then when we compare just blinded data, compare with sarilizumab, they compare with this critical case. The patient need a high oxygen support. They have the mortality rate, the high dose sarilizumab, 23%. And in our case, our high oxygen group, we have 7% S rate. So at the end, in the summary, we think this CD25C really target this very important multiple part of this COVID-19 pathogenesis, including the lung inflammation, including lymphopenia, cytokine release syndrome, and the coagulation abnormality. And we think right now, no drug can address all these 4 challenges at the same time. So we consider this CD24FC could be the real game changer, can really save life and really make the difference in this COVID-19 pandemic. So I'll end it here. Thank you very much.
That was an excellent presentation from your end, from Pan Zhang. So we are really happy to have you talk. And so any questions for Dr. Pan Zhang? I think no questions from anyone. Okay, that's with that we are moving to next presentation. Next presentation by Dr. Pedro Gonçalves de Oliveira from the University of São Paulo, Brazil. He is going to speak on a potential multi-target therapeutic drug for COVID-19. Hello, Dr. Pedro, can you hear me? Hello. I think Dr. Pedro is having some issues with his connection. Okay, then now we have a presentation from Orlando M. Gordon. She's from Avani Foundation, United States. She can't turn up to the conference because she is busy with some professional works, but she had sent an presentation as a video presentation. So now we are going to share a video presentation by Orlando M. Gordon from Avani Foundation, United States.
Good morning. I'm Dr. Linda Gordon, President of the Aveni Foundation and Director of the Biological and Immunological Therapies of the Cancer Center of Southern California. First, I'd like to thank the organizers for inviting me to speak at this meeting. Today, I'll be talking about the Corona study, Deltarex G targeted gene therapy for COVID-19. The Aveni Foundation is an IRS-sanctioned 501c3 public charity whose mission is to expedite the development of tumor and gene-targeted technologies for cancer and other unmet medical needs. Founded in May 2018, the Aveni Foundation's initial goal was to raise $10 million for specific projects that aim to develop new cancer therapies without the toxic side effects of chemotherapy. However, in response to the global pandemic, we have embarked on a new mission, the Corona study using Deltarex G as treatment of COVID-19, now adding $5 million to our 5-year goal. Pro-inflammatory chemicals or cytokines that cause raging fevers and damage to the lungs and other organs. macrophages occupying the lung tissue with decreased alveolar airspace and fibrin deposition. to evaluate whether in an otherwise normal, healthy population infected with COVID-19, whether Delta Rex G would have the same safety features. Secondary objectives include to evaluate treatment outcome parameters, including clinical status, example, time to resolution of fever, improvement in respiratory rate and oxygen saturation, length of hospital stay, need for mechanical ventilator therapy or intensive care, and changes in cytokine pattern.
Well, identify novel beta coronavirus SARS-CoV is an agent of COVID-19. It has single-stranded RNA and several spikes here and in red here. These spikes bind on the receptor on host cells in blue, mediant viral invasion. The human cells and tissues that will target the SARS-CoV-2 depend on receptor expression. SARS-CoV-2 invades host cell mainly via two receptors: angiotensin-converting enzymes ACE2 and CD147. The DPP4 also can be SARS-CoV-2 receptor, but is a null-MERS receptor. We can see here SARS-CoV-2 and spike ectodomain. The specific region of spike that binds the ACE2 is the RBD, receptor binding domain. But DPP4, there are little evidence that SARS-CoV-2 bind to DPP4 receptor. And about CD147, on the other hand, there are several evidence that SARS-CoV-2 binds CD147 receptor. This CD is a highly glycosyled transmembrane protein of the immunoglobulin superfamily, and it has two domains, domain 1 and domain 2, and has three asparagine here and here that can be glycosyled. Wang and co-worker demonstrate that SARS-CoV-2 also binds CD147. They use co-immunoprecipitation, immunoelectron microscope, and ELISA, and humanized anti-CD147 antibody to demonstrate the new routes of viral invasion. CD147 acts as a main upstream stimulator of matrix metalloproteinase MMPs. CD147 can be upregulated during asthmatic and diabetic conditions. In addition, the expression level of this CD and MMP are often increased in inflammatory process. Studies have shown that patients with severe asthma and have high levels of NNP9 sput and influenza A virus in its asthmatic increase CD147 expression. In addition, other studies showed that high glucose concentration increase CD147 expression in monocytes too. It's well known that NNP functions in monocyte migration. So inhibition of CD147 could have a beneficial effects in prevention of diabetic complications involving inflammatory process, including COVID-19. As an anti-CD147 antibody that block infection with SARS-CoV-2 in vitro, binding in domain 2, and its humanized drug, metaluzumab, has been already used in clinical trial, this in patients with COVID-19 pneumonia. This clinical trial in phase 2 is current in China, and meplazumab seems to facilitate viral clearance, return the normal levels of lymphocytes counter, and decrease the CRP. The percentage of treatment the percent of improvement of patients with severe COVID-19 is higher than meplazumab treatment compared to patients with conventional treatments. And meplazumab demonstrates safe profiling. Interesting, the same CD147 is a receptor not only for SARS-CoV-2, but also for Plasmodium falciparum. Entry this is Plasmodium falciparum entry to erythrocytes. Plasmodium falciparum is a protozoan that causes malaria in humans. We can see here that the protein of parasites binds to CD147 on erythrocytes, and this interaction was essential for invasion by all tested strains in vitro. Moreover, experiments in vivo with meplazumab also demonstrate that the inhibition of this interaction block the invasion and cure infection in humanized mouse model of Plasmodium falciparum. Interestingly, the azithromycin acts also as an inhibitor of erythrocytes invasion. Flow cytomer experiments and experiments of live video microscopy show that azithromycin quickly acts to prevent the essential step of junction formation very early in the invasion process. Removal of two glycan groups of azithromycin induce a loss of invasion inhibition, and other derivatives of azithromycin present different invasion inhibition activity. fact, there are some possible mechanisms by which azithromycin can prevent invasion. But the fundamental step in this invasion process is the ligand-receptor interaction. So the interference of azithromycin in this point interaction should be considered. If confirmed, this drug may provide a novel therapeutic strategy against other pathogens that invade cells by CD147 such as SARS-CoV-2. We can see here the spike protein, and here too, and with RBD and NTD and terminal domain. And by molecular dynamic simulation, it was demonstrated that azithromycin, ATN, can bind NTD domain and in conserved amino acid triad. We can see here A, B, and C subunity of spike. Note that the B and C subunity also display azithromycin bind sites. In the suggested mechanism, azithromycin could act as competitive inhibitor of SARS-CoV-2 attachment on the host cell. Besides the invasion inhibition activity, azithromycin also has immunomodulatory effects, and for this reason has been administered for therapy of chronic inflammatory conditions such as bronchiolitis and autoimmunity disease. The mechanism of immunomodulatory effects are still little known, but several studies show that azithromycin promotes alternatively activated macrophage phenotype, M2, in cystic fibrosis and chronic obstructive pulmonary disease, for example. So, azithromycin could serve as immodulator by promoting M2 macrophage differentiation in SARS-CoV infection. In addition, a study from Gill and co-workers with rhinovirus demonstrate that azithromycin induces antiviral response in human bronchial epithelial cells. This drug increases interferon, and interferon stimulates gene expressions, so decrease viral replication. In this study, Torres and co-worker screened several approved drugs in infected cell-based assay. Azithromycin presents antiviral potency with AEC 50 of 2 micromolar. This concentration is similar to the concentration that will be found in lungs in humans. And this concentration is a little bit higher than remdesivir, 1 point. This study was realized with MOI 0.002. But with MOI 0.2, azithromycin did not present effect. MOI is a relation of viron to host cell. And about human recovery, the largest clinical trial remains studying the possible effect of azithromycin. This human clinical trial show the positive and negative results of other drugs have been already published, but the recovery trial remain recruiting patients from azithromycin group. And about indomethacin. Studies suggest the beneficial effects of indomethacin. Indomethacin is a COX-1 and 2 inhibitor used in clinical for its potential anti-inflammatory properties, and it presents antiviral activity against several viral pathogens, such, for example, indomethacin also has a potent antiviral activity against SARS coronavirus. Its antiviral actions were first discovered with canine coronavirus and SARS-CoV-1, block the viral RNA synthase. Indomethacin was subsequently shown to be active against SARS-CoV-2 in vitro. Importantly, the antiviral effects were seen at normal anti-inflammatory dose levels. And about the human, SARS-CoV-2 in human. 3 controlled trials of oral indomethacin for COVID-19 is now recruiting in USA and Italy and Iran. About the mechanism of indomethacin. Studies with other viruses have shown that indomethacin acts independent of COX action, activating PKR. Indomethacin induces PKR activation independent of interferon and double-stranded RNA. And PKR phosphorylates this factor. These events result in block of viral protein translation and inhibition of viral replication with IC50 2 micromolar. Indomethacin also is a prostaglandin. Indomethacin also is a prostaglandin E synthase 2 inhibitor with its IC50 of 0.7 micromolar. Interestingly, Gordon and co-workers demonstrate that prostaglandin E synthase 2 interact with viral NP7 protein. and in SP protein is a cofactor of RNA polymerase from SARS-CoV-2. So indomethacin could affect the expression of viral RNA by this mechanism and block the viral protein translation and inhibition the viral replication. So more large experiments with human are necessary, and we wait new result in this file. Thank you very much for this opportunity. This is our group.
Hello, Dr. Michel, is it over from your end, your presentation? Hello, can you hear me? Professor Michel? Yes, we thank you for your presentation, and it was a wonderful talk. And so any questions from the group? Okay, the next.
Yes. No. Yeah, I have a question. Do you hear me?
Yeah, I can hear you. Yes, you can throw. Yeah.
Okay.
Yes.
My question is if they also do investigate the effect of their combination of drugs on micronutrients like zinc and other nutrients. Do they take this into consideration? And so yeah, that's my question.
Yeah, it's a good possibility because you know some evidence this point this way, and
but it is not done yet. It is not done yet. Not yet. Okay.
Not yet.
Yeah. Okay. Yes. Thank you.
Yes. Thank you so much. Yeah. Thank you so much, Dr. Michel. Now the presentation from Dr. Miku Singh, Shasta Cascade Health Center, United States. And now he will be speaking on COVID-19 reaching remote populations, new hotspots emerge in rural USA.
Hi, good morning, everyone, or good evening, wherever you are. I'm hoping you're able to see my slides there.
Yes, we can.
All right. So my topic actually is COVID-19 new hotspots in remote US, mostly in the rural and farm working communities in the US. Now, this is a bit of a different tangent here based on epidemiology standpoint, but then also from the new emerging viruses which is emerging and spreading new infection rates in areas which we haven't thought earlier. I work at Shasta Cascade Health Centers, which is a federally qualified health centers. It's just a backdrop to give you an idea where I'm coming from. And we serve rural patients in California, primary farm workers, farm working communities, remote patients, underserved, uninsured, Medicaid patients. So the PowerPoint presentation is coming from that point of view. There are about 60 million Americans who are living in the rural US currently, and that has started a new phase of pandemic starting May of this year. Most of that infections are coming from meat processing plant. The workers who are working there in the meat
Do the slide view. Right now it's very small.
Is it better now?
No.
Sorry.
No, not yet. Yes, no. Yes, good. Thank you.
Better now? All right, awesome. Okay. So there are about 60 million Americans who are living in the rural US. Most of them are farm workers or factory workers. And that has started a new phase of pandemic now here with those people who are poor residents, poor rural residents that now have become the new hotspots for the infection and spread of the infection. Most of them work in meat processing plant. A lot of them are factory workers. They are seasonal farm workers. And they are the ones that are now increasing the hospital bed capacity in rural hospitals and rural nursing homes, rather than as equally, or I would say not even less than, but maybe equally as compared to the urban counterparts. There are out of 25 rural counties with the highest per capita case, 20 have been from the meat packing plant. And that includes most of the rural counties in the U.S. Those people working in those meat packing plant or the prisons where the virus took hold and then spread with the men and then kind of leaped into the community when the farm workers or the factory workers went to their homes. The reason for that again is because working in those meat packing plants, it's a low temperature, chill temperature. It's a good environment for the virus to spread. Poor sanitation standards also add to that, to the spread of the virus and to the growth and infection rates of the virus. As per CDC data in June, which is the last week of June, there have been 5,000 cases in the workers at almost over 100 meat plants, meat processing and poultry plants in 19 states in the US, and most of them are again coming from farmlands or rural and remote areas. 86% of rural counties had at least one COVID-19 case. 1/3 of the rural counties had at least one COVID death. This is a very recent data starting first week of July itself. Then there have been surge in new cases, infections in rural migrant farm working communities. It's very alarming for us because those are the communities which are anyhow poor. They have no access to healthcare, have no insurances, and they live far away from any nursing home or for that matter, any rural hospital. Most of those people already have other comorbid health conditions. Diabetes, hypertension, obesity is much more common in rural patient population as compared to their urban counterparts. And then on top of that, there is a huge need of increasing the capacity for the beds in the rural hospitals or in the skilled nursing homes located in the rural counties in America. There have been about 2,000 rural hospitals in the US. 2/3 of them have 25 or fewer inpatient beds available, and more than 50% of those rural hospitals are already operating in the red. They are about to close their operations because of no revenues, so that adds to the problem here. Poor housing and hygiene, another to top it off. Rural immigrant farm workers, they already live in poor housing. The hygienic standards are below standard conditions. That's again a very perfect environment for the virus to thrive and spread the infection and the transmission rates. And then it's important that migrant farm workers should be looking very carefully by the government here and the public health department if we really want to bend the curve. I think not a lot of attention has been paid by the public health agencies or the government, especially in the US, towards migrant farm working communities or farm workers or factory workers or people living in rural and remote areas at all at this point in time. That is the reason that it's becoming a new hotspot of infection now. Most of the farm workers in rural US live in California, Texas, Idaho, Florida. Those are one of the largest states in the US, and those are mostly migratory seasonal farm workers. And from seasonal farm working standpoint, that has become a new line of spread of infection. Migratory farm workers are those farm workers which are traveling. They are seasonal. They travel from one county to another county, one state to another state based on the harvest season of the crops. So now it's very difficult when the infection spreads from them or they become the host of the infection because there's zero contact tracing rate. The public health department is almost unable to contact trace those seasonal farm workers because every month or every 2 months or every quarter they are traveling from one state to another in search of jobs or for the harvest season. You can't even quarantine those patients because number one, you can't contact trace them. So how would you know if they have the infection, or how would you quarantine those patients? And then there's a huge lack of COVID testing in rural US. Where I work, we have almost 50% lack of testing kits provided to us. Poor access to preventive care also lack of public health support. And then farm workers, mostly in the US, they lack health insurances. They are anyhow very poor. Sorry, most of them are undocumented and they could be immigrants, either from Latin America, Mexico, or elsewhere. And so they are actually trying to make their both ends meet, help their families. So because of lack of health insurance, lack of their paperwork, lack of immigration standpoint, they are super afraid to go to any clinic or any public health department for a basic testing or a checkup, because they fear that if they go into a public health department or a clinic like ours for a testing, they might get deported, or they might be told to not work, papers might be taken away. So that's a huge fear factor in agricultural farm workers of actually going for a testing. Another thing is that they're unable to speak English, so sometimes that's another barrier to care there. Child labor is huge in farm working communities in the US, and when those children work with the parents who are infected, they are also getting or kind of getting themselves exposed to getting those new infection rates. So all in all, the transmission rates and death rates are increasing. There's a huge spike since June and in rural farm working communities. Right now, the government or the public health departments do not really have a great plan or any action plan for that matter on how to flatten the curve there, because most of the attention is paid to the urban communities or people living in big cities rather than people who are farm workers or especially seasonal farm workers. So I do suggest that the government could work on that. But that's that from my end. It's a pretty short and crisp presentation. Would be open to answer any questions if you have.
Mike, this is Mihir here.
Yes, I can hear you.
Yes, so it's a really very important topic that you talk about. So do you have any kind of data like with regards to this, like apart from publicly available data, which can be utilized to maybe create a case? And maybe bring notice to the government and local public agencies?
I mean, the only data that I got from, like, some data that I have from my county where I work, is currently which is a pretty rural county, we are getting 10 new cases each week. That is in one rural county in California. That's our data. But the data that I got from CDC very recently was 5,000 cases in June, which happened actually in the last 2 weeks of June. Alone, 5,000 new cases. So that's the data that I have gotten. But we do have each county at their own level have their data, which we report to the county. So based on my county, there are about that many new cases that are happening.
Okay, because I will be talking. So one of the research work that I do is like I try to use machine learning techniques to make county level prediction for USA, taking
Right.
into consideration urban and rural health. So I got a lot of insight, like more about what kind of things I can include in my model to effectively predict. So just wanted to say thank you. It was a informative talk.
Sure, and I think you're Meher, right?
Yes.
And Meher, you can contact me through email. I think the organizers would have my email, and I can always share with you, because every week the data is coming to us. So if you want information on at least my county, which is one of the largest rural counties in California,
Okay.
it's called Siskiyou County. I can always give you that data also. The organizers will have my email, so please feel free to contact me, and I'm happy to share that too
Okay.
on a weekly basis or a monthly basis.
Okay. Sure.
Definitely, Mr. Mehra, we will be giving you Dr. Miku's email address so that you can throw your questions or you can ask whatever you want to ask him. So now we are moving on to next presentation, that is by Dr.
Can I ask one question? Sorry.
Yes, you can.
You have a clinical trial ability. Do you have a hospitalized patients?
So yes, we have done that. I mean, the nearest hospital, so I'll give you an example where I work. The nearest hospital to my rural clinic is 100 miles away. So the patients have to be airlifted in case of emergencies or life-threatening situation. So the hospital has been doing it, but the data, there's such a disconnect between us and the hospital because of the distance, and that's the case with most of the clinics in rural areas, that the nearest hospitals are also about 50 to 100 miles away.
So what do you do when the COVID-19 patient get really sick? You just airlift all of them to the hospital?
In emergency cases, even we have airlifted. Other than that, yes, it's an emergency transport that we do. We do have that availability to travel, to take them for, to give them a ride and take them all the way from our center to the hospital. But many a times, last month we had airlifted 3 people who were almost in a life-threatening situation, and they were 75 years of age. So that it's a big bottleneck here in these areas, definitely.
So I don't know whether you hear my talk or not. So we have this phase 3 clinical trial. We can really make the mortality rate down to like a 4% in 2 weeks. So it's just really save a lot of life if you can use our drug. So that's what I'm trying to pitch in to get more site. Right now, most of our clinical trial site at the beginning have this hot spot in East Coast area, but right now they have a very, very low rate. We have a very difficult to enroll patient now. So we are trying to make our site move more to Texas, Florida, California. But it's just a lot of competition to us. But we feel our drug really, really good.
Right. Great.
So if you are just a patient, just starting to need oxygen support, I think your clinic still can handle that group of patients, just have the supplement oxygen like a nasal cannula. Then
Correct.
We can really make the patient out of the discharge to home, completely recover in 3 days.
Hmm. Interesting. Maybe I'll connect with you offline
Yeah,
then after
yeah.
the conference.
Maybe we'll share the email address.
Yeah, yeah.
Yeah. Thank you.
Awesome. All right. Thank you. I appreciate it. Thank you.
And one more thing, Dr. Miku Sodi, I would like to tell you from organized point of view. So we already recording the all presentations. So I think you missed Dr. Pan Zhang presentation. So we'll be sharing the recorded version of the conference to you. So you can go through her presentation, and offline you both can connect to emails as well. Yeah.
Yes, please. I'm sorry I came late to the conference because I came at 6:30 a.m. in US California time. I was sleeping in the night when the conference was happening in CET time. So my bad. I apologize.
That can be understandable. And thank you so much for joining us, Dr. Miku Sodi. Now, next we are moving to the next presentation by Mihar Mehta. She's from Pennsylvania State University, United States, and the talk she's giving on early stage prediction of US county vulnerability to this COVID-19 pandemic. So now you can go ahead with the presentation, Dr. Mihar Mehta. Yeah.
Okay. Okay. Can everybody see my screen? Hello.
Yes, Mihal, we can see your screen.
Okay. Okay. Hello, everyone. Mm, My name is Mihir Mehta. I'm pursuing my PhD at the Industrial and Manufacturing Engineering Department at Pennsylvania State University. Before I begin to talk about my research and other details, firstly, I would like to take an opportunity to thank organizers to present me an opportunity to uh, mm, give more insights about the research that I conducted during the early stages of COVID-19. Okay, so the research work that I did, its title is Early Stage Machine Learning Based Prediction of US County Vulnerability to COVID-19 Pandemic. Even though I'm presenting this work today, I worked along with Juxihan Juleti, Sundar Kumara, and Paul Griffin on this particular research work. So uh, uh, if you noticed, when I started presentation, I said hello, because that would be universally applicable to all the participants which are in different time zones. So if I have to create a great greeting like good morning for US based people, good afternoon for Europe, and for the others, maybe good evening, or for some of them, good night, I'm based on where you live. I'm trying to design what kind of greeting I should make. So this is a kind of a basic decision tree, which we will come to in our talk. So today I will first tell you the overview of my research. What is the problem statement? How we solve that problem statement using a model, and how we evaluated that model, what results we got, and what conclusions that we can make, and references and a few appendix slides. Okay, so let's look at a quick view at my research. So what is the problem that we are trying to solve? It's to develop early stage county level prediction around near future disease movement for COVID-19 occurrences using publicly available data. We will come to the problem statement in a bit, but in order to address this problem, we develop a 3-stage model using XGBoost machine learning algorithm. And the results that we got showed sensitivity over 71% and specificity over 94%. And it shows for early stage, there is a positive association between urbanicity and vulnerability. And what is the importance of this result? It helps to identify vulnerable counties in near future so that health organization can effectively plan their resources and workforces. So let's look at the problem statement carefully. There are 4 components to it. First is for early stage of COVID-19 pandemic. Second component is develop prediction around disease near future moment. Third is these predictions should be at a county level. And what kind of data do you want to utilize for that? It's publicly available data. Why this problem statement? So let's go back and look at each component, what it brings to the problem statement. So if you look at early stage COVID-19 challenges, there were limited testing resources. On February 29, FDA began to open up testing. And again, we just heard there are still limited testing resources in rural USA. So there are back then, there were limited testing resources even in urban areas. Again, hospital had limited resources to manage COVID-19 patients. Business entities were not prepared for the challenges imposed by COVID-19 back in February and March. So the only intervention that was possible was non-pharmaceutical intervention. So the national emergency was declared, 15 days lockdown was to slow the spread, and then it was extended. So what these timelines tell you, like where we are now, like nobody expected that we would come that far with COVID-19 challenges. So those were the early 19 COVID challenges. Apart from the risk factors were not known, much known that time. Again, during this time, near future risk prediction has benefits. It gives you short reaction time to plan and prepare. Also helps you in prioritizing your efforts. And the purpose of using publicly available data and open source programming is any organization can leverage this method. And again, back in early March, around 5th March to 10th March, it was an early stage attempt to gather COVID-19 associated risk factor data at highest level of granularity. Okay, now the question remains is why county level prediction? So US is one of the largest countries in the world by total area. It has 50 plus states and territories. And if you look at counties, there are 3,200 plus counties, which is clearly seen in this map. So what it does, it introduces a lot of heterogeneity at a county level on different aspects, which are demographics, socioeconomic, health profile, and environmental. And all these factors are very essential in deciding your COVID-19 spread in early stages. This is an example how the population under age 18 will look like across different US counties. So you can see there is a lot of heterogeneity. Again, and the final challenge was at early stage of COVID-19, there were limited data availability sources because when in early stages of any disease or any process, the granular availability of high level of granularity is always limited. So Johns Hopkins University was providing county level data till 6th or 7th March. And then for a temporary basis, they changed their granularity level. And the only available resource at that point was 1.3 acres website, and that too through web scraping. NY Times did a really novel efforts to provide county level data, but that data came from 22nd March. So if you look at this graph, that is when that repository on GitHub was created, which is halfway through the early stage of COVID-19. So we wanted to make predictions at these granularity, so effective decision making can be applied. So again, going back, what is machine learning? Machine learning is learning about data without explicitly programming. So depending upon whether you have explicit availability of outcome or not, your methods can be classified as supervised learning or unsupervised learning. Let's say if you have outcome availability, whether that outcome is continuous or categorical will classify methods into regression or classification. The model that we built uses regression and classification techniques. And the model that we built is algorithm is XGBoost. So let's go back to my early talk when I said how you will grade is a simple problem of example of decision tree. Okay, so imagine all the people in this conference design their own metrics and features to reach to a conclusion how the grading should be. So you will aggregate those results and the majority wins. That is called bagging. Now, if you look at it, we allowed everyone independently develop their decision and come to a conclusion. But what if I start and I make mistakes and the next one learns from it? That is boosting. So when bagging and boosting combine, the gradient boosting trees algorithm is generated. And if you make some good mathematical adjustment to it, a XGBoost algorithm is generated, which has its really good prediction powers. Now we talked about algorithm and the techniques. Let's look at the data that we collected. Obviously, the first thing is the response variable. That is number of COVID-19 cases, which we define as occurrences. So this is a response to a response of our stage 2 model. And using these occurrences, we created an instance variable with two labels. One is positive instance and other is negative instance. So for a given day, counties which reported 0 occurrences were classified as positive instance, and counties with greater than counties which reported 0 occurrences classified as negative instance, and greater than 0 were classified as positive instance. So let's look at what kind of predictors we collected. Always the impact and spread of an epidemic dependent upon population factors and locality. So we utilize US Census data and RFJI's data resources for management of hospitals. Okay, even though all things look good, there are multiple limitations to our work. During early stage, there were a lot of fluctuation in daily occurrences. So due to limited availability of testing facilities. So in future, to improve this model, we need to account by some kind of parameter at our third stage of model. Similarly, the occurrences which were observed over every day, they showed increasing trend for coefficient of variation. So that also need to be accounted in your regression model, that is stage 2 model. And again, given the time sensitivity and the purpose of the research, we included limited number of predictors. Again, one part of XGBoost is you effectively tune the hyperparameters, which we did. But the another important factor is better feature engineering. That is where our model can definitely improve. And we can use stacking methods to improve the further prediction powers. So I would like to thank my uh, research partners, Juxihan Juleti, my advisor, Dr. Saundar Kumara, and Dr. Paul Griffin for their wonderful insights and motivation throughout this research and at every stage of the work. And I would like to thank again Sciinov Group for organizing and giving me this opportunity. Uh, so the paper, our paper is available on MADE archive. Currently, the paper is under review for a journal. If you are, this is the paper link. And if you are interested in the coding aspects, the code is also available online. And if you have any questions or want to discuss anything, please feel free to reach out to me or my advisor, Dr. Saundar Kumara. These are the references. And thank you very much. And I will take if anybody has any questions.
So any questions for Mr. Mehra? So thank you so much for your wonderful presentation, Mihar Mehta. We're really happy to have your presentation at our conference. And so now we are moving on to the next presentation, that is by Sciinov Insights. Apart from the conferences, Sciinov Group is already offering Insights. So that session will be taken care by Anant Reddy from Sciinov Insights. He is our technical head. He will be now taking you through our insights databases. Yeah.
Hi everyone. Yeah, I think it's a welcome again from Sciinov from other division. It's a Sciinov Insight Services. So we have intelligence offering. So we cater to different intelligence data sets for pharmaceutical industry. So why we are representing now is, so we are emphasizing the industry trends and also the pace of these industry trends across different sectors, like whether it is a clinical trials or regulatory designations or patents or like drug development or different country approvals and pipeline. So we're gathering data. So by the industry trend, like targeted therapies, vaccines, gene therapies, fusion proteins. So which are the advanced therapies? So we made a kind of innovative step to gather all our related innovative drugs data at one place, to have drugs, clinical trials, companies, patents, regulatory designations, drug sales, and technologies, everything into one place to give to the researchers or to the strategic people in the organizations very simple manner, not to have a complex databases, simple searches. So also we support customized data inputs, whether it is small or big, whichever the way the data size you have, so we can support. And also we can work along with you in terms of customization of your interested data sets. So for example, so we have already gathered some of the industry recent industry trends, and we already have a data here. But within this, if you want a granular data again, yes, so we are here to help you, to provide you with the granular data for all the like predetermined topics from the Sciinov. Okay. So as a overall, like, we have intelligence platforms, trends and analysis. Within that, again, industry trends and industry insights. So under industry intelligence, under intelligence platform, sorry. So we have again, right, press intelligence. Like this database covers complete real-time news across the globe from pharmaceutical industry. All companies' news aren't, whether it is a research or regulatory approvals or any related drug-related or clinical trial results related, we try to capture under press intelligence. And also drug intelligence includes more than 40,000 drugs within the database to, like, showcase the coverage of your data interest. Company intelligence to provide, like, how many public or private or specialized companies by headquarter, so we can provide within a simple clicks. I'll just show you the database once this presentation is quickly over. And also we have a clinical trials intelligence. So we capture more than 1,20,000 clinical trials, mostly United States, but we have a coverage, started coverage for the EU and other geographies as well. Technology intelligence is then again one more a kind of a innovative platform wherein, so we studied mostly like close to 800 to 1,000 technologies across the drug development, drug discovery, drug formulations, and these 800 to 1,000 technologies applies to more than close to 8,000 drugs. And also we have a contacts intelligence database wherein we have close to 1 lakh contacts. So by department we have the contacts it will give you a business leads to you. And also drug pricing database. So we gather drug prices from United States, from UK, South Africa. So whichever like publicly available. So we are gathering by strength and by the BA class or ATC code. So we are gathering and we are trying to integrate all the data, all the possible data for a drug in a single database platforms. And again, generic intelligence, like what are the generics available for the branded drugs. So industry trends, as I said, that predetermined selected topics we have in the industry trends. Also in the industry insights, whether it is a regulatory insight or indication based insights also we are offering. Okay. So the purpose is that we will keep you up to date, and then also this is not a complex database, and we are going with very user friendly packages, pricing packages. We can go even monthly also. So it will be affordable for individual also. So that will definitely help to access the most up to date data to a smaller say smaller sections also. It's not like we need to pay thousands of dollars to subscribe the databases, right? So monthly will definitely affordable for individual level also. So that's a pricing strategy we have, so we can support you for the betterment of the pharmaceutical industry and for the industry or individuals growth. So we are trying to customize our database offerings. Our resources are truly expertised in making you a tailor-made offerings to make your business or to make your research more meaningful and more target oriented. Yeah. So as I said that, so these are the industry platforms, intelligence platforms we have. So these are the trend reports which we have predetermined, but yes, we are going to add few more on a timely basis. So the trend reports, why we pick the trend reports? Because more trend is towards the biologics or personalized therapies. So wherein the complexity of the research is too high, and also the success rate of the drug is very very high risk. So with this regard, so obviously, as just now Mihir said, that predicting the result based on a current data, so which will definitely save a lot of money. So with this aspect, so we try to give every corner of the data, whether it is a similar therapies available, and what are the clinical trials results were happened with that particular drugs, and also so what are the competitors are like, how they are approaching. So what are the development strategies, so how they are moving from one phase to another. So and then what kind of regulatory information they have populated in the clinical trial submissions. So this and all will be provided, so that you will be well aware before you plan for the regulatory filings. So, and then we have a small biologic and reformulation drugs, wherein the investment is moderate, but advantage here is that the success rate for the small molecules and reformulations will be little high. So this particular the companies do get the public offerings, or the grants and everything, and then investors, so private equity and venture capitalists show interest in these funds, because these are the less risk companies. So in their portfolio they want to include some of these companies as well. Okay. So industry insights. So some of the sample insights what we are going to offer is that what are the previous historical approval drugs by year. For example, I just populated for United States, but we can offer for Japan and Canada and EU. So these are the four countries. So we have data for the country level drug approvals, and by again application type. So with BLA 505 251A, how many? BLA 351A is an innovative pathway, and 351K is a biosimilar pathway, and 505B1 is the NME pathway mostly, and B2 is like extension of the already available drug. So these are the industry insights, type of industry insight we gather for the sake of better informed decisions. So we try to collate a ready-made data, try to offer. So to the context now. Now we are talking on the COVID drugs. So we cover the COVID-19 drugs, and as of now in the database we have 251 United States companies which are working on the COVID-19 drugs, and followed by the China 39 companies, so Canada 34 companies. So these are the top 10 country headquarter companies working on the COVID-19 drugs. And these are the split, like so Novartis has a major number of pipeline drugs, with 2 phase 3 pipeline drugs it has in the COVID-19 therapy. So it includes both the therapies as well as the vaccines. So this list includes. So this is the kind of the company's activity towards the COVID-19 treatment. So we just try to keep a small analytical data set. But if anybody is shown interest to have a complete data, so please do contact us. So we'll try to tailor made as per your needs. Maybe you don't require everything here, but we can make it pieces, and relevant information we can share with you. So if you see the stages wise, so approved therapy is 6, and phase 3 we have 53 drugs, and phase 2 we have 118 drugs, and preclinical 235, and discovery we have 200 drugs. And also, so we do cover 700 plus pipeline drugs, and more than 1200 plus clinical trials, 600 plus companies, and 800 plus news and deals as part of our intelligence platforms. So I just said that we have 6 approved drugs. So these are the drugs. So Favipiravir from the Chromis, Coronavir from R-Form, so Ilcira from Biocad, and Altlegia from R-Form, and Veklury from Gilead, Covifor from Hetero from India, and Favipiravir from Glenmark, India. So there are compassionate use drugs already in development, so which are being already in treatment, existing treatment options. So they are trying for the COVID-19, so which are going in a compassionate use pathways. So already, the compassionate emergency use authorizations has been given for 2 drugs. One is Gilead's Remdesivir in United States, and we have Eliva. Red Hill Pharma has been granted for the expanded access program for this particular drug. Okay, so these are the some of the slides we gathered for COVID-19. So anybody has any question or any requirement, please you can raise a question now, or you can email us later.
So any questions from anyone regarding Sciinov databases and insights and trends and analysis? So here we are at the end of the day where we can go ahead and close this conference. We as organizers are really happy and want to thank all the speakers and attendees who were able to participate even in this pandemic situation and tried their best to share their best research in COVID-19 and helped us in making this conference a great success. Thank you so much once again, and hope to meet again in the upcoming conference. And the next quarter Q4 COVID-19 conference will be announced in coming week, and the dates will be announced very soon, and we hope all will reconnect again. Thank you so much for joining us. We hope you enjoyed the conference. And coming to certificates and your proceeding books and the recorded version of the meeting, we already sending you certificates and proceeding book by tonight, and the recorded version of the conference will be sent hopefully in a week time. Dr. Miku Sin, I hope I cleared your question. We hope we'll meet again in our Q4 conference, which will be announced very soon. Thank you so much. Have a wonderful day.